So while dealing with evaluation of machine learning models, till now we have been talking about a train and a test data set. So that's the essence of cross-validation. Cross-validation is actually taken into account by using seen data and unseen data. So you train a model using some seen, that's the seen data. Now you need to actually check how will this model perform in the real world. So you have separated some of model data. That will be the test data. Now if there's a difference between the train data performance and the test data performance, you kind of understand how your model is going to perform on an unseen data set. That's the basis of cross-validation. Now, how this would actually work is, let's say you have around 100 samples of the entire data, like 100 training records. Out of that, you create 2 samples. Now, the general thumb rule is to actually divide into a 70 and a 30. So, train data set would actually contain 70%, that is 70 records, and the remaining 30 goes into the test data set. Now, you use this train data set to train the algorithm, and then you use the test data set to as the unseen data set to see how it performs. So this is something which we have been doing so far. Now, there are further extensions to actually go ahead and leverage this to a new level. That will actually help us be more confident about how our model will perform and probably take the best parameters of a model. Now, the train data set can actually be split across further 2 segments, which is, let's say, a train dash set, which is, let's say, a subset within the train set, and a validation set. And now we create multiple samples of training set and validation set. So let's say out of a 70 that goes into the train set, we use a combination of 50 and 20, and we create multiple models. And in each of these models, we kind of shuffle between train and the validation set. Let's say model 1 will have 50 in train set, 20 in validation set, and then model 2 will have another set of random train set with 50 records, which means that the train set which had 50 records over here and the train set which had 50 records over here might not be completely same. It's a randomly shuffled data set, and it will validate the data set using the validation set, and then kind of improve the parameters during the learning process. Now in this process, you actually create several models with some sort of variation between the training and the validation set, and then finally you take the best one to leverage and see how does it perform on a test data set. Now that's cross validation in a more deep and in a more extensible way. Now there are different techniques of cross validation. The most popular one would be k-fold cross validation, where k stands for a number. Now how does k-fold work? So let's say we take 5-fold cross validation, or let's say 10-fold cross validation. The most popular would be, let's say, 10-fold. So what it will do is, we have the whole data set, again, let's say 100 records. Now this whole data set is divided into a 70 and 30. So we say train set has 70 and test set has 30. Now k-fold cross validation takes into account the k number, which is over here, let's say 10. So what it would do is, it would divide the train set into 10 equal partitions. So here it has 70 records. So these 70 records will be divided into 10 equal partitions. That is, it will have 10 partitions with 7 records each. Now it will use 9 of these partitions, that is, let's say 7 into 9, 56 records to actually train, and the remaining one data set, one partition to test. And this process it will do 10 times, where it will keep changing the validation set with a new data set. So let me show this to you pictographically. So assume that this would be your train data set, or this is the whole data set, and this would be, let's say, approximately 100 records. Now out of this, we create 2 partitions. So the first partition would be around 70%, and the second partition will be around 30%. Now this will be the this will be the train, and this will be the test. Now out of this train, we'll actually create, since it's a k-fold validation, the k is equal to, let's say, 10. What you do is, this data set, which is the 70%, will be divided into 10 partitions. Let's create 10 partitions. 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it's actually a little misaligned, but then just assume that you have 10 partitions over here for simplicity. Now what it'll do is it'll actually leverage 9 of them first for training, and the remaining just one of them for test for validation. Now this will be iteration 1. In iteration 2, it will take a newer set, that is, instead of this one, it will take, let's say, these 9 partitions for training and this one partition for testing. And that process will continue. In the next iteration, it will take, let's say, this partition for validation and the remaining for training. So you have 10 partitions. It will create 10 iterations, and in each iteration it will choose one new validation set. So when this process repeats, I apologize for the handwriting, but then when you repeat this process 10 times, out of these 10 partitions over here, you would have selected one partition for validation and the remaining 9 partition for training individually different times across 10 iterations. So at the end, you'll have 10 different models where you'll have learning, the training data set, which is kind of different. Now, once you're done with the main thing, what you do is you'll take the best model. Let's say model number 5 give you the best results, or you can take the average, and then you can leverage that best model to test on this unseen data set and see how your model is performing. So that's K4 validation. A more extensive version of this would be leave one out. So instead of creating 10 partitions over here, leave one out would be, let's say, just leaving one single record. Let's say out of 70, you're leaving out one, and you're using 69 for training. And you repeat this process n number of times, and would be over here at 70. That's leave one out. So there are a couple of more techniques over here under cross validation. But in cross validation, in a nutshell, is used to improve the model's performance and helps you be more confident about your model will actually be a more robust or a more generalized version that will be performing better on unseen data also. That's about cross validation. Let's move on to the next topic.